Mountain glaciers are also referred to as valley glaciers, but are also referred to as alpine glaciers. Key to understanding a mountain glacier is they begin as what we call a cirque glacier. And so a very, very upland area, what ends up happening is a bowl-like depression forms, and that snow compacts and compacts and compacts in that depression. Eventually that snow overflows that cirque, overflows that bowl or that depression, and starts to flow outward down a slope. So we can see that in various animations to follow. And so as that glacier grows, it's going to spill out and go down into the valleys. And those valleys oftentimes were created previously by rivers that came through the area. And so one of the things is rivers we know have a characteristic V-shaped valley, whereas in the case of glaciers we see a very polished U-shaped valley. And so one key characteristic that distinguishes erosion from rivers and erosion from glaciers is the shape of the valleys that they create. And we're going to see more evidence of this to follow. Further, at the snow line or towards the glacial boundary of a mountain glacier or an alpine glacier, we get that sediment that is deposited. So we get this collection of sediment that's been plucked, and abrasion has moved closer to the mouth or the end of a glacier, and eventually when that melts, it's going to then essentially drop that sediment in place. So once again, the snow line is the lowest elevation where snow in an alpine environment is going to. And here's one way to showcase that natural transition as we go from the left to the right, a V-shaped valley that has been over time modified by water, creating even a deeper V-shaped valley that then in a glacial period and during an era of very, very cold temperatures, but of course some high precipitation, we're then going to see a different shaped valley that's created, a U-shaped valley. And so eventually when that glacier melts, we'll see over there at the right that the V-shaped valley has become a U-shape. Other reasons we can get cracks and crevices is just simply we think about folding, we think about tension being released from plate tectonics, and so this is just a simple way to understand, okay, well, how can we have cracks on the surface that then eventually can become river valleys? Well, that's just one simple way to showcase that with folding or uplift, all those various plate tectonic processes we've already talked about. Here we see V-shaped valleys, which are a clear indicator of, once again, river erosion. Here we have a cirque. And so cirque is where we're going to have snow collecting. So snow might go down that steep slope and collect here in this cirque. And so this bowl over time gets deeper and deeper and deeper, especially if we go through a very, very cold, but also a very, very snowy, icy period. This is a good way to showcase and emphasize the whole kind of chain reaction of weathering, erosion, transportation, and deposition. So originally we got the freeze thaw that would occur up in these upper parts of this mountain or this upland. And so what that's going to do is physical weathering processes is going to create shattering and then create these sharp angular fragments. Further, plucking, because we're going to get this downslope, and this ice is going to be moving downslope, of course, is then going to take that shattered angular fragments and pluck it away, remove it, and further create this situation where we have erosion that then further brings this plucked, broken down rock bits down to the bottom, where we're going to again get that smoothing to occur as other bits of rock rub up against other bits of rock. But eventually this glacier is going to move all this broken down sediment to the front of the glacier, where we have this deposition that's going to eventually collect here at the end. And another way to showcase these cirques, how they grow, and so over time a snowy period, and so these bowl-like depressions, they grow. And eventually coming out of that depression is the glacier as it moves down slope. And it typically goes into those valleys that were previously rivers, which we can see now here has reached its maximum. So we can see this period of glaciation has been quite intense. But like I've said before, way before humans were here, we would have these warming periods that would leave behind the features that were created from glacial erosion. So key to understanding glaciers also is the fact when the ice melts, it leaves behind these very distinctive features, including these U-shaped valleys that we see here. So these distinctive characteristic shaped valleys, even the gray ones, would be these U-shaped, unlike the rivers that produce V-shaped valleys. Now here, take us back to this slide here. It takes us back to this whole idea of movement, transportation, deposition, and so forth. So that what happens when all of that water is removed, when all of that ice is removed, what's going to happen is we're going to have that sediment that's essentially going to fall in place at the end of that that previous glacier that we saw in the previous image. And so essentially what's going to be created then there is what we call a terminal or end moraine. Further, in that cirque, in that depression, of course, what's going to fill that depression, that very low-lying area, is water. And so the meltwaters, maybe from that glacier or from other glaciers further upslope, will then fill that depression, and we call that a tarn. Here's a nice schematic that shows some key landforms that are created during the process of glaciation. First off, we have our cirque here. So that cirque is going to be found at the origins of this flowing glacier flowing down the slope. Further, we're going to have at the end of this glacial boundary, this glacial flow, we're going to have an end moraine. One of the things to note is that end moraine produces this rugged feature that's virtually parallel to the end of the glacier. So essentially we can think of the end moraine being perpendicular or at a 90-degree angle to the flow of a glacier. Further, along the sides, one of the things is the glacier scours the sides as it flows down into these valleys. And so running parallel to the flow of this glacier are what we call lateral moraines that are on the sides of this flow, of this U-shaped valley. Finally, when we have two glaciers that come together, two mountain glaciers that come together, we typically have this rugged feature that's found right in between the two, and that's called a medial moraine. And so that would be another one that for the most part follows the flow, as far as the direction the moraine goes, follows the flow of the glacier that's flowing down the slope. But of course, after all that ice melts, we're going to get these distinctive landforms that are created. In this case, we see that distinctive U-shaped valley, but this would also be a good example of what we call a glacial trough. Oftentimes in these glacial troughs, you also find another distinctive characteristic feature, and that's what we call ribbon lakes. They're called ribbon lakes because they're very long and narrow, because they follow the very much that valley shape. So all across this U-shaped valley, in this trough, of course, the water is going to collect here in these rather deep lakes that are found at the bottom of a U-shaped valley. Here in this we see, first off, this massive glacier trough, but also we can see a ribbon lake here of that water source. But there's two features we see towards the top. We've got what they call arêtes, a French term. So when you have two U-shaped valleys that are parallel to each other, so essentially two alpine glaciers that ran parallel to each other, that then essentially fed this bigger, were tributaries that came into this bigger U-shaped valley, one of the things they'll notice is they have very much this sharp, almost knife-like feature. So what we see is a very, very sharp top to that rugged surface there, and that's what we call an arête. It is simply the in-between parts of a U-shaped valley. Further, when one of these tributaries might actually dump into a bigger U-shaped valley like we see here, we can see this very steep slope there, and that's a hanging valley. So that's where a previous glacier fed into a bigger one, but then of course when everything melts, produces pretty much a cliff here. And so oftentimes in these alpine areas, this is where you're going to find waterfalls as they come falling, crashing down from a hanging valley. And it's a nice cool aerial that kind of shows the various things we talked about on the previous slides in the landforms that have been created. You can see all kinds of hanging valleys, arêtes, we can see the U-shaped valleys, and so here we can see glacial processes in action. And of course, you know how, like, for concepts to build and build and build, here we have Mount Rainier, which is located out in the west coast, and we can see the rain shadow. We can see over here a quite dry area and a quite wet area to the left. And so here we have a good amount of precipitation. But one of the things we can see this white area. Well, why is this area white? Probably because it's at a higher elevation. So we know that in this area of the country, we're going to have subduction, and that subduction is going to create volcanic features, like Mount Rainier here. So Mount Rainier is in an area, if it wasn't for having this cone-shaped volcano due to that subduction, this area would be quite green. But because of a higher elevation, because as we know we can go up in elevation, we know we're going to get a cooler temperature, combined with the marine west coast climate, which brings a lot of precipitation to this area, you're going to then get a good amount of alpine glaciers here. So key there is the elevation, but also the precipitation. So climate and topography play a key role. And so coming on all sides of this cone-shaped volcano, we can see alpine glaciers carving and eroding away